Hi there. Welcome to Databricks Data and AI Summit. Thank you very much for coming along to Neo4j's lightning talk. I'm here to take you on a whistle-stop tour through how Neo4j and Databricks can solve some of the challenges of getting GenAI into production. My name is Stu Moore. I'm a Senior Product Manager at Neo4j. And I'm here today to talk to you about GenAI and our recently certified connector for Databricks, Neo4j Databricks Connector. I'm sure we're all aware and familiar about some of the breakthroughs in GenAI, from boosting employee productivity, improving customer experience, improving predictive analytics. That is, after all, why we're all here today. But what I wanted to spend a bit of time just talking about was some of the challenges with GenAI. Like any new technology, when it comes to market, there are specific challenges that have to be overcome. And if we think about LLMs, they're no exception. I'm sure many of you here today remember the introduction of Google Search and how it revolutionized how we found documents, websites, and content on the internet through their PageRank algorithm. But GenAI, the stakes are kind of much higher. When you looked at a set of search results from Google, you had tens of thousands of sources to pick from. You would maybe browse the first top 10, maybe the first top 20. You would select the content that you felt represented truth. That's becoming harder to distinguish today. But the onus was very much on the person doing the searching and selecting the content. LLMs kind of remove the visibility of the data sets that sit behind them and how they kind of come up with their decisions. And what you get back is a very authoritative response written in very confident language that kind of makes you believe, and generally probably is the best answer in many situations. But you don't really get responses going out, "Oh, I'm not too sure here," which you might get if you went and asked a person, depending on their seniority, tenure at a company, and their knowledge and background. So you kind of get lulled into this sense of security that LLMs are giving you the best possible answer. And most of the time, that probably is true. But I just wanted to take a couple of international examples. Obviously, this is predominantly US conference, but people are from the rest of the world. And some of these may not have hit the US media. There was a case a couple of years ago where a Canadian traveler was looking for a refund. He had to go and visit his grandmother's funeral, and he asked an AI chatbot on the company's website if he was entitled to a bereavement refund. The chatbot told him it was. He took the flight, then he tried to get reimbursement. The company declined the expense and said he should have applied for the request before he flew. He took them to court. And he won. The judge ruled that it was a common sense decision and essentially set a precedent that your company is responsible for GenAI and the answers it gives out just as much as it would be if an employee had been on the other end of the phone giving that Canadian traveler his answer. He was awarded $812, enough to cover the flight and some of the costs. But what's important here is it sets a precedent. And as we'll see in the next example, precedents are really, really important in the rule of law. It's basically how it works. There was a case in the UK where an individual was fighting against HMRC. That's our equivalent of the IRS. And her lawyer used, I think, ChatGPT to ask questions about case law that may be relevant to her case. Unfortunately, there was some hallucination on the part of the LLM and the chatbot, and it came back with this kind of amalgamation of two genuine pieces of case law, and it figured on the balance of probability, if that one was true and this one was true, then this piece of case law that didn't exist should help. The judge, obviously being super experienced, knew that there was no such piece of case law and threw the case out, and they lost. In New Zealand, there was a case of ChatGPT describing how a dispute between a landlord and a preschool was about beehives on the property. The LLM reasoned that because the school so happened to be called honeybees, that's it, honeybees school, that because there were honeybees at the school, there must be a beehive at the school, and therefore the dispute was about beehives, which wasn't in fact the case. Now, these might seem like small, fun, trivial, they're not earth-shattering in terms of impact, but if we take GDPR and how the EU has helped step up the game against how companies handle data and data privacy for individuals, and levying fines of tens or hundreds of millions of dollars, and knowing that the EU, and I'm sure the US as well, are going to start to legislate and put in protection around GenAI, it's not unreasonable to assume that in a couple of years' time, there could be frameworks available that suggest, if you are negligent and you haven't put in enough effort around how GenAI helps and provides answers, that you, like the Canadian airline, might be held responsible. Now, obviously, with all great tech, we've already started thinking of the answers, right? There's retrieval augmented generation, and this is basically there to help overcome the fact that obviously LLMs are trained up to a point in time, and they're trained on public data sets, and there are questions over copyright and whether that is right, but I'm not going into that here. What's important for the enterprise is to be able to provide enterprise context information. So let's just look at how, and I'm sure many of you here will be familiar, and one of the challenges with a lightning talk and a mixed audience is knowing how much people know about different things. I'm going to cover a lot of stuff quite wide and not assume anything around what people understand about Neo4j. So you ask ChatGPT, you provide a prompt, it goes back, searches its data model, and comes back. Supposing the query was, hey, when's the Data AI Summit this year? If the model had been trained back in November 23, it would probably give you a response of, oh, it's the 26th to the 29th of June. And guess what? If you relied on that, you'd probably all be late. But it could even say, well, actually, based on the last 3 events, I figure the probability is it's going to be around about, and comes up some random date. So how do you overcome this? This is where grounding the system with retrieval augmented generation, i.e., fancy word of saying going out to another data source and getting the latest information. And that's how us enterprise companies can ensure that we get the benefits of LLM with the latest information. So Databricks could plug up their marketing data sources, other information that they want to make available to the public, and they can go, okay, right, it's the 9th to the 12th of June, and we'd all turn up on time. And this is a process that's referred to as grounding. Now, when you've got a large amount of data, and I'm sure as you're all Databricks customers, you've got a large amount of structured data sitting in Delta tables. You've probably got some video, images, unstructured data that you need to make available. And there are techniques like vector and vector databases that can help you encode very complicated images, video content by analyzing it and producing an array or a vector of information that describes the similarity of that content compared to other documents or images or videos. And it's a very efficient way of compressing all that information, that rich information, down into essentially an array of numbers. But you've got many sources of information, right? How do you get your LLM to go out and know when it needs to query the unstructured data, the structured data? That's something you need to think about, right? And at Neo4j, we've been solving these types of problems with what we call a knowledge graph since 2007. Essentially, a knowledge graph is a superset of all the information in your organization. This means that we take the most important information and the data, not necessarily the volume, the entire documents. We can link out to those and have those stored in a third-party system. But the crucial important information that you need to make decisions on. And knowledge graphs help employees be more productive. Now, I'll be going into how Neo4j's label property graph works in a few slides' time. But I just wanted to highlight that although our partner-validated solution happened this year, we've been working with Databricks customers for the last 4 to 5 years. And we've now got 85 customers. They include AstraZeneca, Elsevier, the research publication, Novataris, across 5 key verticals. There are others as well, but these are like the most popular, from energy utilities, pharma, healthcare, supply chain. That was particularly booming during the COVID challenges, and financial, where it's great for helping with financial crime. The popular use cases, you won't be surprised to learn that the number one is knowledge graphs, like internal for the benefit of the employees. And this is very similar to what you want to turn out and provide to your external customers, along with cybersecurity, social networks, and entity resolution, which can help identify fraudulent or people who've got stolen identities. So our partner-validated solution can help you graph inside your Databricks Notebooks. The Neo4j Connector fully supports running there. We support the Unity catalog, Delta tables, and Databricks' new compute engine, Photon. We're fully secure when it comes to analytics, ISO 27001, GDPR, SOC 1, SOC 2. So that kind of brings us on to like GraphRAG. So you won't be surprised to learn when you call out to a graph for retrieval augmented generation, we called it GraphRAG. Marketing didn't have to work too long for that one. This enables you in your enterprise to call out to a knowledge graph of information to help improve the response of chatbots or other LLMs that you want to implement. So let's talk a little bit about how Neo4j's labeled property graph works. The graph concept was obviously invented by Dijkstra in 1957. And Neo4j have taken that concept and extended it further, enriching the graph with labeled properties. So you can now describe more information about those nodes and relationships. So I'm just going to take you through some of the fundamentals of Neo4j for those of you who are unfamiliar. So labels, like you have nodes, different types of nodes. Nodes are things, like nouns, so people, cars, and then connecting those nodes, you have relationships. Now, relationships are unidirectional. If you want to specify a bidirectional relationship, like John knows Jane, and Jane obviously knows John, then you create relationships in both directions. This is important because not all relationships are bidirectional. So only one person is legally responsible and allowed to own a car. You don't have joint ownership. It's not like a house. So Jane owns the car. John drives the car, right? And one of the other restrictions is you're not allowed to have dangling or hanging relationships. A relationship has to have a node on both ends. And this is where the more descriptive aspect of a graph and native graph comes in by providing properties on those nodes and relationships. So now you can describe characteristics of the car, the person, their age, their relationship, how long they've been married, one of the other things you can do is take a vector and generate vectors on nodes. So that then gives you a numerical representation of how similar 2 nodes or 3 nodes may be, enabling you to index on those nodes and create node property embeddings. Now, Neo4j's native graph relies on a fundamental principle that's very different to how SQL databases work. And this is something called index-free adjacency. And it's how we're able to do really deep searches really fast. And that's because each node stores a pointer to the next node. We provide a variety of indexes and search capabilities. These, you may think, oh, hang on, you just said index-free adjacency. We use indexes to find the starting point of the graph and where you find like a particular object. And then we're able to do your deep, fast searches really quickly. So if you put all these together, you get GraphRAG, where you're able to query down through the LLM and retrieve information from your graph database. There are 4 graph patterns: text to cipher, where you can provide a text response and get it converted into cipher; graph vectors, where you're storing the vectors in the graph; and then combining a vector search with a graph context to get even better results. So over on booth 47, it's over by Theatre 1. We've got a great demo. I'm just going to give you a sneaky peek of that here now. We hook up to the Microsoft Northwind database, the fashion retailer H&M, and we've got this Streamlit application. It's not our product UI. It's available in GitHub. And I think this kind of really demonstrates the value and the benefit of combining vectors with a knowledge graph. When you ask a pure vector search, give me the 3 most popular cheeses and how are you ranking popularity, it can tell you those 3. It sounds convincing, but it's based on stock, not really how you would measure. So instead, if you add graph context to that search, you get back 3 different ranks, but importantly, it's chosen the popularity based on the number of orders, which is a far more sensible value. And I'm kind of running out of time, so I've got 40 seconds left, but this is a lightning talk, so I'm going to shoot through. We've got a visualization library called the Neo4j Visualization Library, and there's a prototype we're developing that enables you to run that as a Python library inside a Databricks notebook. And you can see a demo of that on our booth. So you can now visualize a graph inside a Databricks notebook. Just wrapping up, we've included some resources. So there's the GitHub repo, and there's some free resources, learning materials. Thanks. Sorry I didn't leave time for questions. You can come and beat me up afterwards for not giving you time there on the booth over on 47. Have a great rest of the event. Thank you so much. A quick picture before you all disappear. Thank you very much.